This is Unit 10, Organic Chemistry, Lesson 5, Functional Groups. How does the addition of functional groups change an organic compound? The objectives of this lesson: I can identify functional groups, and I can name substituted hydrocarbons. Do now. And 3 and 4. The functional groups can be found on Table R in your reference table on page 8. Use the following table when you have more than just a hydrocarbon. So that would be when you have oxygens or nitrogens or halogens added into your organic compound. To name or draw substituted hydrocarbons, use Table R. Use the example given in Table R, which is the far right column in Table R, and compare it to your problem. Locate the class of compound, which is the far left column in Table R, and see how it is named or drawn in the example. Use that example as a model to draw or name your problem. The halides have one or more of the halogens as a branched group. You first name the chain, then you add the halogen prefix. In this example, I have a chlorine here, so the halogen prefix is chloro. I have 1, 2, 3 carbons, so this is a prop. I'm going to number where that chlorine is, so this is 2-chloropropane. A second example is I have a fluorine here, so the halogen prefix is fluoro. It's on the first carbon of my 3-carbon propane, so it's 1-fluoropropane. If I have more than one of the same halogen, use di, tri, etc. to name them. So here I have a bromine and a bromine. I have 2 bromines, therefore I would name it di-bromo is the prefix for bromine. And I have 2 carbons, 1, 2. So I have 1 bromine on the first carbon and 1 bromine on the second carbon. So I have 1, 2, dibromo. Ethane is my 2-carbon compound. The next class of organic compounds is alcohols. Their functional group is an OH group added anywhere on the molecule. I first name the full chain and then I add the suffix EOL. So here is my OH functional group. It's on the first carbon of my 3-carbon chain. So this is 1-propanol. A second example, here is my OH functional group. It's on the first carbon of my 4-carbon chain, so it's 1-butanol. Ethers have an oxygen bridge dividing 2 carbon chains. You first name each chain, then place in alphabetical order. This example is the only exception where I have methyl ethyl ether. So here's a methyl group with 1 carbon. Here's an ethyl group with 2 carbons, and they're divided by my ether oxygen bridge. So now I say methyl, ethyl, ether. A second example is here's my oxygen bridge, and on either side I have a methyl group. If they're the same thing, then I'm going to use di-methyl ether. Aldehydes have this functional group where they have the CHO on the end. And the suffix, you'll name the chain and add the suffix Al. So in this case, I have 1, 2, 3 carbons, so it's a prop. And that functional group with the CHO is add the suffix al, so it's propanal. A second example, I have the functional group CHO on the end, and I have 1, 2, 3, 4 carbons. Therefore, I have the butanal. The ketones have this functional group with the double bonded O in the middle of the chain. It's always in the middle. I name the parent chain, and I'm going to add "-one" to the end, and then I have to number the location of that functional group. So in this case, I have 1, 2, 3, 4, 5 carbons. That ketone functional group is on the second carbon, so it's 2-pentanone. My second example is here's my functional group. There are 1, 2, 3, 4 carbons, so that's the bute. The functional group is on the second carbon, so it's 2-butanone. Organic acids have this functional group, which we call the carboxyl group. It's abbreviated COOH. You first name the parent chain, then drop the ending and add suffix oic acid. So I have 2, 3 carbons, so that's a propanoic acid. My second example, here's my functional group, the COOH. There are 1, 2 carbons, so that's an ethanoic acid. Esters have the functional group, the O, the 2 O's here in the middle. Name the chain bonded to the O first. So this chain is bonded to the O, therefore this is a methyl group. Then you're going to name the chain with the double bond. So here's my double bond. It has 3 carbons, 1, 2, 3. So that's a prop. And you're going to add the suffix -ate. So I have methyl propanoate. So a second example, here's my functional group. You first name the chain bonded to the O. So this is an ethyl group. And then I have 1, 2, 3 propanoate. Ethyl propanoate. Amines have this functional group where they have the NH2 group, and that could be in any place. So I name the chain. 1, 2, 3 makes this prop. The amine is on the first carbon, so it's 1 propanamine. The functional group NH2 is on the end. There are 2 carbons, so it's ethanamine. 1 ethanamine. Amides are different than amines due to the double bonded O. So they have the NH2 with a double bonded O. Name the parent chain. 1, 2, 3 carbons. So that's propanamide. I'll add the suffix. My second example, name the full chain. 1, 2, 3, 4. So that's butanamide with the double bonded O. So we'll do a couple practice. Here is a ketone group. It's in the middle, the double bonded O. There are 3 carbons, so it's a prop. So I'll label this 2. This is 2. My mistake. 2 propanone. 2 propanone. Name the following. Here is our amine group. 1, 2, 3, 4 carbons. The amine is on the end, so butanamine. Name the following. Here's our functional group. It's a carboxylic acid. There are 1, 2, 3, 4 carbons. So this is butanoic acid. All right, check your understanding. And now you can identify functional groups and you can name substituted hydrocarbons.